let's make sure and try to give Sarah our full attention as she goes on about for better in training, research operations, do OpenStack orchestration. So we'll learn a little bit about OrcheStrack.
Okay, so that was actually like a for loop, FYI. It doesn't come off that way when you read it. But so I'll just start off with the obligatory about me. And this is like sudo YAML, so just to kind of get you used to that, because we're going to look at a lot of YAML formatted files today. So this is just to kind of like break you in slowly. But my name's Sarah. I'm really happy to be here. A little bit about me, obviously. I love to teach and I love to learn. And I've always been able to learn more through teaching because I just push myself to understand things more and better and, again, do OpenStack better. And in that, I'm forced to learn. So I like to share the things that I pick up along the way. And this talk is really about, using something that a lot of people tend to think is a really difficult thing to use. And I'm not here to say that, no, it's actually really easy. It's not. Just like any good tool, it is probably hard to use, and it is probably going to take you some time to be able to use it. But an analogy that I've used a few times is if I give you a screw and some boards and a hammer, I mean, you can get that screw through those boards with a hammer, but that's not really the right tool. So OpenStack really isn't the right tool for everything, but if you know how to use your hammer and you get presented with, a bag full of nails, then you can do a much better job at doing whatever it is you need to do. There's a lot of different interesting applications, and I'll talk a little bit more about that. Just from a broad perspective, like why would you use OpenStack? Again, it's about what do you need. So I'll try to elaborate on that. And then down here, and I'll make sure that anyone that's interested has this link for later. This is the area on GitHub where you can find the Git pages. There's a tutorial. Everything that I'm going to go over today is probably going to be a lot and very fast. And I know that, sometimes you need something to go back on. And so there's a more robust write-up of all the different things inside of OpenStack that you need in order to create an environment to work inside of. And so that's at this GitHub pages, and then also at the GitHub repository. Again, it's all public. Are all the examples that I'm doing today so that you can actually use those and play with those. And at the end, if you want to come, get with me and just like leave me your email, I can get you access to an OpenStack range so that you can actually test these yourselves and play on that for a limited amount of time. I will ask you to sign something that says you will not do bad things. But outside of that, again, all the templates, they'll be there for you to use and replicate what I'm doing, or get creative and try to build on those and really, kind of see what it's all about. So again, about me, Trash Panda is the GitHub handle, and I'd just like you to know that I do very much relate to raccoons. Trash pandas are adorable, cute, fuzzy little creatures that for me are like a favorite animal right under cats. But I think cats, like everyone, I saw a guy here today with a cat on the back of his shirt riding a shark that was vomiting a rainbow. So I think I'm in good company. I figured I would highlight my dual love for the trash pandas. All right, so before we get into how to create the environments inside of an OpenStack project, we kind of have to get a foundation of OpenStack, what you would use it for. I need to talk you through some of the vocabulary because honestly, even if you've used virtual machines before, some of the vocabulary that we'll use or see inside of an OpenStack flavored environment is a little bit different. So specifically, when we're talking about using OpenStack, I want everyone to just remember, if you don't know much about it, I'll let you know that it's not a hypervisor, it's a cloud framework. So just like AWS is a cloud, OpenStack is not the best option if all you're looking for is a hypervisor, because guess what? VirtualBox is free, right? You can put that on your computer. ESXi is free if you don't want it managed under vCenter or something. If you need a hypervisor, just use a hypervisor. But if you need a cloud, then use a cloud. And there's a lot of things that you can do with a cloud because a cloud allows you to take a large pool of resources and manage and allocate and manipulate those from separate areas. It allows a lot of flexibility with scaling. And at least under OpenStack, you have a lot of opportunity with the open APIs that whole premise, that whole framework is built around. So from a security perspective, and again, there's probably a lot more that I'm just going right over in terms of what you can use OpenStack for, but from a security perspective, having a way to very easily create a secure sandbox where you can, do malware analysis or whatever, fuzzing. I think honeypots would be a really fun thing to, be working on and putting out there on a cloud. Analytics is another great one because, again, the scaling power that you have there allows you to kind of, consume the resources you need, but scale out as necessary. So again, when we look at security and analysis and things like that, those analytics, that gives you a really great opportunity. And of course, testing and training. I didn't mention it before, but I've been training for a long time, as in like training individuals in different aspects of technology and security. And I find OpenStack a really great environment for creating playgrounds to train people in. One of the things that I specifically like about it is the way that you can create templates and you can start from fresh and you can deploy things, and when you need to make either a minor or a major adjustment, that can be done in a really simple, quick fashion versus me booting up my VM, going in, making all my changes, saving a snapshot of that, and then that's my next glob of stuff, right? I can capture all of this in a code repository. I can use version control to look back at the changes, to compare things. So there's a lot of flexibility with putting things in a templatized version, or a templatized format, and really kind of focusing on the code. So that's why I think this is cool and important in a nutshell. I hope you're still with me. So let's talk about vocabulary before we get into the technical stuff. And I will warn you that at some point I'm going to switch out and I'm going to do like the most dangerous thing you can do, which is live demos. And so I'll be opening up a PowerShell window and then I'll switch to the code. And so it's going to be all over the place a little bit. But some vocabulary that you need to be familiar with. So right here you'll see a template, right? And a template it has many different pieces to it. The template itself, you'll see HOT and CFN. We're going to be discussing HOT, which is the heat orchestration template, not CFN, which is the cloud formation, that's AWS. There is compatibility inside of OpenStack for CFN to an extent, but we're really going to focus on HOT because that is the most robust set, and obviously it's fully compatible because it is the OpenStack standard. So that template can be represented in YAML or JSON, for example. YAML is the style that is preferred in HOT. CFN, of course, you can see JSON or YAML. I don't know, how many JSON fans are in here? Oh, I'm sorry. I don't like it, okay? How many Python fans are in here? Okay, so you know how in Python indentation means something? So that's how YAML is. So if you've never experienced YAML, it's a beautiful thing because indentation means something. It's also a terrible thing because tabs will screw you up because it wants two spaces always. So if any of you have ever done that before, and it's white space, it's not fun. But again, that's kind of one of the things that I love about YAML versus JSON is I just get a little confused with all those curly brackets. I like the indentation, and it's familiar to me based on having, a Python background. So looking at the template itself, the template is what is going to define for you what you are going to deploy into your project. And when I say project, again, remember that we're talking about a cloud. So in this cloud, as a user on the cloud, I'm going to apportion you, allocate you some resources. So that portion of resources that are yours, however many CPUs and however much RAM that is, that's your project. Inside of that project, you can build whatever you want. You can put one VM in there, and I say VM now just to ease you in slowly. I'm going to start calling them instances, which is what the language is inside of your kind of OpenStack world. But you can put one in there, or you can put many that are on one network, or you can put many networks, and you can put appliances, so you can do all sorts of things in there. But the template is what defines all of that. It's really the code that configures your environment and puts those resources there. And so the template itself has several different sections to it. So that first section, parameters, that's optional. Parameters allows you to feed information in. And that you'll see more on later when we actually go into the examples. For me, I don't know about you, but it's a lot easier to absorb some of this when I see it happening. and I see the application. So that's why there's going to be a lot of live and demo so that you can see the application of how we evolve and create these templates. So parameters can help us to define certain values. We can pass those in. They can be used against resources. Resources are the things. So it could be a server, for example, and I say server, that's what the resource is called. We're going to say that that's a VM or an instance. So it could be a server, it could be a router. So there's a router inside of this, and that's a software-defined thing that is able to connect multiple networks that, you know, you can add routes to, you can, you know, do whatever you need to do. You can filter. So those are your resources, and there's many, many, many more, and we'll look at some of them, but those are the basic ones that you know you're going to need. So that's where we have to start, is with the basics. And then some other optional areas here you'll see at the bottom, outputs and conditions. And so when you look at a template, the first part is parameters, and then you have resources, and you have outputs and conditions at the end. Again, those are optional, but we'll look at some, you know, fairly common and easy to recognize reasons why you might use output or conditions inside of your template. So everything inside of that template, like I said, that's basically in code an architectural drawing for what's inside of this project, all the things that you want to have. That gets passed off to Heat. Heat is the orchestration engine working on behalf of OpenStack. You might have noticed, and you'll definitely notice when I pull back out, all those like funny little pictures at the bottom of my presentation. There was like Cinder and Swift and Keystone and Glance. All of those are projects inside of OpenStack, and so here you'll see that Heat is doing the orchestration, but what facilitates that and really what it's working with are those other projects like Glance for images and Keystone for identity management and Nova for your compute and all of those things. So all of those are feeding into Heat, and Heat is using the specifications you've given it in the template along with those projects in order to produce those actions, and you get a stack. And so the stack is a collection of those resources in whatever configuration you've defined. And so you see there I have this little snapshot of like a network topology that you would see from the Horizon dashboard of OpenStack. And so, you know, Heat deploys your stack, and there you have it. Now I can go in and start to operate on and mess with my different items in there, routers, servers, etc. So in a nutshell, again, these are some pieces, and you'll hear me talk about this more. Why templates? I'm just going to stress again, templates are very useful. It makes it a lot easier to deploy things, to make changes, and that's really important when we talk about the life cycle of software and capturing that from a security posture. If this one thing needs to be updated, it's a lot easier to do that from a template, again, as opposed to spinning up this glob of information, making that change, and then saving it again as another glob of information. It's also really important to think about, again, from a security perspective, automation and orchestration as added value. Automation is going to cut out the user error risks, and it happens. I'm a terrible typer. You guys will probably witness that today, unfortunately. But automating repetitive tasks and orchestrating things can really streamline what you do and cut out a lot of that user error. So, with OpenStack, I will tell you this. The documentation is a little scary. And not only is it scary, but as a beginner, if you dive into the documentation and you don't know where to find what you're looking for, or you're not exactly sure what you're looking for, you might give up on OpenStack. And I can understand that, and I won't hold it against you. But I'm going to tell you that if you know where the documentation is and you start to try to find those places, it's going to make what you do a lot easier. So right here I have two links. One is for Red Hat's documentation, and the other is for the community-driven documentation for the OpenStack, you know, the community-driven code. So what I highlighted in these is 14 and Rocky. Okay, so on Red Hat, we're talking, this is 14, that's where we're at, and in the community version, that's Rocky. So Rocky is the version that I'll be doing the demos on, and then you can see up here I have some of the subsequent versions, Stein and Train. So those are as that evolves. So again, if you're looking at something that's Rocky and you want to look at the Red Hat equivalent, it's 14, so don't jump into 15 or 16 because you're not going to see the same thing, and I don't think I have to preach to you that if you're not looking at the right documentation, you might not be getting the right information, and so there might be compatibility issues or more commonly syntax inconsistencies or changes that are going to mess you up, and that's not fun. All right, and so last thing before we kind of jump in is accessing the cloud. So you're going to see me access this cloud environment in two different ways. You're going to see me in the Horizon dashboard, which is the GUI way of doing things. By the way, if you use OpenStack and you're going into the GUI and you're spinning up everything, like you're creating your subnet, you're creating your router, you're creating all your VMs through the GUI, because you can. If you are doing that, that is taking you a lot more time than is necessary, I promise you. And it's really annoying, and that's probably why you've given up on OpenStack. So I will tell you that it's good for beginners, and it's to kind of get an idea of what's in there and what you can do, but ultimately, getting your hands on the client and really, just kind of working with the templates is just much better. So I'll switch between these two. The dashboard is just easier for me to show you. After we make that template go do its thing, I need a visual representation and the consoles to prove to you that it's not just smoke and mirrors. So we'll jump into the GUI to look at the environments that we're spinning off out of these templates. And then API, I'm not going to go over that today. I was playing with it a while back, and I got the session, the token, and I passed that off, and it all works, but it's also terrible. It's terrible. And it's not really something you need to worry about unless you're a developer, you're administrating it, or there's some sort of implementation that you're trying to work. But to be honest, as terrible as it is to work with, I just hate it. The documentation on it isn't too terrible. And this is coming from someone that really doesn't enjoy it. It's not too terrible. It is out there. I will caveat as well, as far as for client use, when you go into Horizon, there is a place where you can download a file. You're going to source that in your Bash terminal, and I'm not going to be using Bash. I have a Windows client with me. Please don't hold it against me. But I'll be using PowerShell. So there's no real good instructions online. There's actually a guide on installing the client and using it with a Linux machine that's very easy and simple to follow. But as far as using it on Windows, it's actually very easy. You just download that file, and in that file, you're going to see all of these variables. Just create environment variables with those names and put the value in it, and it works in PowerShell. It's that easy. It really is. So again, I'll be using it in PowerShell. All right, so now we have to get started. So I want a single instance. Remember, that's a virtual machine. That's all that is. So I have to start slow, and I want a single instance. Okay, if I go to the documentation online for the open source code, okay, and you see that highlighted there, this is what I have. This is sort of terrible, okay? The resource. Type, now that's important. Properties, I have a long list. Okay, flavor, string, disconfig string. This is a long list of stuff, okay? Now, I would have to actually go to, and I'll highlight that again, the document that gives me the definitions for what's inside of these different resources. So you see there where it says type OS Nova server, that's the resource that I'm looking for. So when you see OS Nova server, that's just like a VM, okay? And so I have all of these different things that I can specify for that. And if I go and I say, okay, well, it says that the flavor is a string, but I'm not sure what that means. Some of those things you are going to be able to find fairly well explained inside the documentation, and some of it, I just recommend you go find someone that's already created a template and steal what they did. Because there's just not a lot that defines what should be there. Again, some of it is there, and some of it is a little bit of a guessing game. But again, I think that this can be overwhelming for someone that has just started. So let's break this down. Before we jump in there, let's look at what we want. I want one single instance, a single VM, and it's going to need 2 CPUs, 2 gigs of RAM, and 8 gigs of disk space, an IP address so that it can talk to the world, and passwords. It's a pretty simple requirement, isn't it? That's really it. Then I can go into it and I can do whatever it is I need to do. So in order to accomplish that, this is what I need. This is the template. And you can't see the very bottom line. Let me full screen my thing for you. Yeah, you still can't quite see it. There's like one line. There it is. Okay. So that's the whole thing. And this would be shorter if I took out my silly comments. Okay. So based on what we saw from the documentation versus this and my requirements, it's a little less scary now. Is anyone still really scared? Because if you are, you should go. The rest of this talk is not for you. It's going to get worse, okay? But again, this is not so bad. So we still have the definition of the type of resource. And here again, I've named it Linux host, but I have the definition type OS Nova server. So I know this is, some sort of a computational, like this is a computer or a server, basically. And then in my properties, I just have the things that I need. Now again, going back to the documentation, it will specify what is a required field versus what is an optional field. All that stuff you saw, a lot of it was optional. If I don't need it, and I'm not worried about that, I'm going to leave it off. These are things that are required, though. So name, that's just like your host name. Image, that's going to be what the host is. Is this an Ubuntu host? Is this a Debian host? Is this a Windows host? And you'll see most of my examples are Linux hosts because of how long it takes Windows to stand up. I do have an environment file that you guys can play with on your own. I'm just not trying to sit here for 5 minutes while Windows 10 gets my environment ready. So I have my image. That's the type of computer that I'm going to be running. My flavor is basically the specifications as far as the CPUs, the RAM, the disk space, right? So if you're familiar with Amazon, AWS cloud, then it should be somewhat familiar to you what we're doing here. Networks actually, when you look at the specification for this resource, networks is going to be something where you have a list and you only need any one of those. You can include more than one. In this case, I just said I'm just going to say network is public. That's a predefined network that exists in here that's allowed to NAT out to the network or to the world. So again, it's a list. So you'll see in this syntax that we have the two spaces to indent things. So resources is left justified, and then anything under resources, of course, comes 2 spaces over. So Linux host comes 2 spaces over, and then beneath that, type and properties, again, get those extra 2 spaces. But I say that to just keep in mind the syntax we're working with. And for a list, you have some options. You can use your square brackets to denote items in a list, or what I kind of prefer, because I don't like the line feed and having these really long lines, I like to actually come down and do like you see here with my dash. Okay, so I can list a number of different items in that list underneath networks. And then user data, this is just raw input for cloud init, which if you need to know more about, there is a link and information on the website that I said I had prepared for you guys. But this is just a bash script that's saying, okay, I want to create a user, the name is user, and I want his password to be security ! And there's my root user. So that's just configuring the host so that I can log in. Keep in mind, if I don't do that, I can't log in. It'll still create the host, but there's no way for me to log into it. All right, so I recorded this one because it's really not that exciting. Oops. Let's see. Is this playing? I don't know, it's not playing, that's fine. We're going to do it live anyways. Basically, you feed it that file, and it produces one host. I did it in a movie because I was going to type something wrong, and I'm like, I'm not going to just waste time on that first example. So now we have a VM. That's not very exciting, is it? No, it really wasn't. So how do we get better? Again, we're just sticking with the concept of one VM. So I have a lot more options, and I'm going to start to add those, and then we're going to get a little crazy, and then you're really going to ask what I'm doing up here, and then I'm going to tie it all back together. So parameters, functions, conditions, and outputs. Let's look at those. This is where I have to break out, and it gets scary. All right, so are you guys familiar with like Net++, or Notepad++, sorry. Okay, so this was my first one. I'm going to open my second one. So basically, this is adding some fanciness. Okay. All right, so I know this is super hard to see. All right, so parameters. If you remember, we had name that was like my host name, just a way to identify that instance. I'm just setting it there. Image, okay? Right here, you'll notice I have image, and again, I have to define a type. It's a string. And the default value for this parameter is Debian Buster, which means that's going to be default what it is, but you'll notice under constraints, I have a list. That list right there with Debian Buster and Ubuntu will show up as a drop-down in the GUI when I go to the dashboard and I try to deploy this. And so that allows me to specify the only values that a user can use and or change, but also have the variability of saying, well, if you don't like Debian, that's okay, here's here's Ubuntu, okay? Flavor, very similar, right? We have type is string, default is going to be CY small, so it's going to take that value by default, and then I have allowed values here, so you can either choose small or medium. User and password, okay, those are self-explanatory. Those get fed as parameters into the bash script. I'm going to actually zoom in just a tad for you. I think it'll make it better. Or not. I'm just going to break something. All right, so down here, this is where we start to incorporate functions. So I defined some of those parameters up top, and I said, okay, image is defaults to Debian Buster, right? So here under image, you see I have get underscore param. It's a get parameter function that's saying, go get a parameter, but I have to tell it what parameter I want it to get. Okay? So image is the name of the parameter in my parameter section, and so it's going to pull the value for whatever I set there. In this case, the default, if you remember, was Debian Buster. So those are pretty simple to understand. And then you'll notice on flavors, I actually have an if right here. So that actually relates to a condition. So in order to understand that, we have to actually jump down to the conditions. So the condition section of this template is where I'm going to set something. So in this case, this is very arbitrary. This is for training purposes, okay? I said image size. So here is my condition, if it equals, and then I'm saying get this parameter for image. So whatever is in the image parameter up top, which again, remember, the default is Debian Buster. If it is left to that, so whatever I get from there, if it is, it should be Ubuntu, okay? So it should equal Ubuntu, right? So we have equals, get this parameter should equal Ubuntu. If I come back up here to the if, this is harder than it looks. If my image size, which again, it was going to get that parameter for my flavor, or sorry, for my image, right, which is Debian Buster. If true, this is what I get. I get CY small. So if you remember, it said Ubuntu, didn't it? So if my image is Ubuntu, if that's true, make it a small size VM. If it's false, I'm going to go to the next thing, which is CY medium, which means when I deploy this, if I leave the default, which is Debian, then what happens? I will get medium, right? Okay, if the user toggles to Ubuntu and that parameter is pulled in and checked, does this equal Ubuntu? Yes, it does. Then I get CY small, right? So there you have a very simple condition. Now, again, I used Linux just because Windows takes forever. But say, for example, you have a very small headless Windows machine versus small headless Linux machine versus I have something a little beefier, it's Windows, I need more, right? Then you can actually build that condition into toggle so that you're taking away the error portion of a user doesn't know better and they choose a flavor that's too small for what they're trying to deploy. All right, so the other thing that I will highlight here in user data, remember before we went ahead and had that bash script? Well, that's ugly because that was a really short bash script. Imagine like that doesn't really give me a lot. I don't want that inside of my template. I want my template to basically be the infrastructure. The guts, I want to put somewhere else because those are going to get messy. So if you notice here underneath the user data, I have template and then it says get file. And this is actually pointing to the repository. And if I was to scroll all the way to the right, you would just see that that is a .sh. It's a bash script that has the same thing that my template had in it before. Understand that it's getting this template because it's going to be feeding parameters into that template. So you'll notice here, there's a string replace call, and that string replace is going to use these parameters, user and password, and it's going to feed those values into that template. So again, the template is the bash script, and so anytime inside of that bash script it sees the variable for user or password, what happens is get the parameter user or password. Now mind you, these match coincidentally, but they don't have to. This right here, the variable for user, that is what I'm calling inside of the template. The get param, this user, that's actually referring to the parameter name, right? So that parameter name is where I'm going to pull that value in, feed that in to my template for that string replacement, okay? And then the last part on here is output. So I said that I wanted an IP address. I hope that this magnification isn't making anyone dizzy. But if I blow this up too much, it starts to cut things off. The last thing is the IP address. That's going to be my output. So in this case, it's just a very simple value that we want to know after creation. Because I didn't assign a static IP. I asked it to just pull some IP from this network that's predefined. And so in my output section, after my stack creates, I can check my outputs, and I can get the for Linux host, which is the resource, the first address. So I'm getting an attribute, and I have to point to what resource I want the attribute from, and then what the attribute is that I want to pull. And so that will become a value that's output to me that I can go and look at later. Now, this is one use case, and we won't get to demoing it in here, but I do have, and it's included in the different templates that I've provided, but we have one where, for example, you're creating users for your OpenStack environment. So the users get created based on an iterative list of, user 1, user 2, and I want to give them some pseudo-random password, but I want it to generate at creation. I don't want it to always be the same thing, and that's the output value. So that's probably a better example where you're going, okay, yeah, that would be something if it's randomly generated, but much like an IP that was dynamically pulled, I would need to output that. All right, so this is much better. Do you guys want me to spin this up, or do you want to fast forward to the next one and see how to make it better? I'm happy to spin this up. Okay, let's do it. You guys are like, we're calling her bluff. Let's see if she can do it. Okay, so you'll notice I have a URL quick ref guide. Oh, let me open it here. Because the templates and the environments, and we haven't gotten to environments yet, but they're all hosted on that GitHub repository. It's all public-facing for you guys to use and play with. But I don't want to type that into PowerShell because we'll be here all day. So I've created this so that I can pull them easily. So right here we have basic resource better. I'm going to copy that, so I've got it. All right, so we're in PowerShell. That, again, terrible at typing. OpenStack, there we go. Okay, so now I'm inside of OpenStack. So what I'm going to do, and I'm just going to show you this real quick, stack create. There is help. I don't even know, yeah, I didn't type that right. So there is help, and it gives you all of what all the things that you might need are. If you just type stack create, like I messed up and said, oh, I don't know what goes there, I put something in there. This is a little easier because you just get all the flags in case you forget. We're literally going to use 2 flags in here, maybe 3. You just need to know TAC T is template, that's easy. TAC E is environment, that's easy. And we might get to the point where I show you how to define a different parameter value so that you can override a default. You're like, well, I don't want the default parameter, I want this other one. So we might get there. So we're going to do stack create. Remember I said TAC T for template, and then I'm going to put in that horribly long URL. And then the last part of that, if I don't know if y'all notice, is stack name. You have to name the stack, and so when we jump into the dashboard, you'll see where that exists. But we have to give the stack a name, so I'm going to call it Better Test. Yes, it worked. Okay, you guys are laughing. You're like, dang it, we wanted to see her sweat. So you can see right now that the stack is creating. It's in process, and I could go ahead and look at the stacks in here just as the same as I could look at the VMs in here. But I'm going to show you inside of the dashboard because it's so much prettier, and we can take a look at the little network and all that. And it is important that you, if you've never used it before. If I was going to create this just through the GUI, just to show you, I would go here to orchestration and under stacks, and you'll see that it's already in there. So there's Better Test. I would launch a stack, and then here I could use a file on my local computer, or I could give it a URL or direct input if I'm just crazy, right? Same for environment sources. Interestingly enough, the environment sources inside the GUI will only let you pull a file or do direct input, but you do have the option to point it at a URL in the client, and so that's what I'll be doing. So here, if I was to put that in, and I'll just show you this for the purposes of this. So remember I was saying earlier how there would be drop downs. So here you have Debbie and Buster. Again, it pre-filled that. That's the default value that I set. These are the two allowed values, and so these are the things that show up there. If I didn't constrain that, basically that means the user could type in anything they wanted, which means it might not be an actual image they can use. So maybe provide them a drop down if we're talking about users that just don't have that level of depth in here. So again, here's where you can change some of those values. I'm not going to create that again here. We're just going to look at here. If I click on this stack here, you'll see that it said create complete. If you mess something up, it'll let you know. You'll get an error message, usually vague and unhelpful. But if you come in here and you go to events, it'll tell you exactly why it failed. It might be that it just didn't understand something or it couldn't create something. And so in the events, and this is just my personal opinion, you get a lot more information to help you get over whatever it is you're having issues with. So I find that very helpful. In overview, you can see right here I have outputs. I mentioned, oh my God. I mentioned outputs was something that we'd want to see. So here we have the outputs. And then I'll just show you very quickly, because apparently I just talk a lot. I have to go faster. Here's my one little sad guy right here, right? And I can open the console and get into him, but I'm not going to go into all that because I want to show you the next template. All right, so the next template is even better. So at this point, we're going to incorporate an environment file. Instead of having all of these parameters listed out, I'm going to put those parameters as default parameters into my parameters on my environment file, and I'm going to use that environment file. And then the other kind of unique thing here is see where I have the resources and I have my host defined. Type says OS Nova host. If you actually go into the documentation, that's not a thing. There's OS Nova server, and that's it. This is a custom resource that is defined in my environment file. You can actually feed it just a YAML right there, but the reason I love the environment file is because I put something really generic here. It says host. I can feed it different environment files depending on what I want that to mean. So if I put a static YAML in here, it's always going to point to that one thing, and that's a Linux YAML, right? If I put host, I can have an environment file that's Linux, and I can have an environment file that's Windows, and that gives me that bit of flexibility. And so that's what I actually did. So in the environments, you'll see like basic Linux, you'll see OS Nova host. This one points to a YAML, which is basically, remember that first one? It was just the basic, that's what it is. It's actually refined a little because it's nested, and then it also uses functions to kind of compress it. So what you're probably wondering at this point as I'm looking at this is, well, yeah, Sarah, that's cool, but now we have environment files to worry about, and I didn't even open those. Well, I did. I opened it. This is just a simple one. So now I have to create an environment file, and I have this file. And oh, by the way, this is just pointing to another nested YAML. So now I have 3 files. You just overcomplicated making one host, right? I mean, I did. Like, it's okay. You can agree with me here. I did. But the point was to demonstrate how to do it with one host. That's not why you would do this. With one host, you would just use one YAML. But if you have a large environment, and that's where, or a large kind of, project that you want to set up, that's where it becomes really useful. That's where you don't have this super long thing. And so in Easy 3 Nets, if you take a look at that YAML, what I'm able to do here is specify sizes of these 3 networks. So it'll allow me 1, 5, or 10 hosts, or I could leave that blank and just say it's a number, put anything in there. And then if I come down, I have networks that are defined. I have subnets that are defined, which again, you can actually make all of that variable information that pulls in. I didn't want to do that to you because it was a lot. I have a gateway router inside of that environment to separate these 3 different subnets. And then here's what is kind of cool. Linux host group 1, you'll notice type is OS heat resource group. So this actual Linux group 1 is a group that spins off any number of Linux hosts, and that's a custom resource that I have in my environment file. So this is registered as a custom resource, OS Nova Linux host 1, points at a very specific nested YAML. So it will spin off as many of these as, if you'll notice, it says get parameter for network size 1. Remember, I had those defaults of 1. If I change that to 5, it means it spins off 5 of them. So it takes that nested YAML which defines one host, and it makes 5 of them. So now I have a network of 5, or 10, or 100, or whatever it is that I want, okay? So let's spin up that one real quick just to see the difference, because I am running out of time. So we'll take this one so that you can see that. So I'm going to first put the template in, and then I'm going to put the environment in. So let me grab that. And this environment has 3 networks. 2 are Linux, 1 is Windows, and it also has a web server. They're all on their own networks. And I had set the default parameter for on each of these. I'm going to try to set the parameter for one of them to 5. So we'll say parameter for network, if I spell it right, 1 size equals 5, because I know that's an allowed value. And then I'm going to say easy test. And cross my fingers. All right, it's there, it created. So now you can see I've switched back over to the GUI. I have easy test. If I go in here, this is just another note, you'll see how they're gray and flashing? So those are still spinning up. These are boxes right here, those are the groups, and so I don't see the host defined individually in this view. I see it as a group because that's the resource type that I defined. I said it's a group, okay? The group itself is a number inside of these nested YAMLs, which contain just one resource each. But if I come up to network view, I can get that fancy sweet topology overview, and you can see what this looks like, and then you'll see my other lonely host off to the side. So there you see that's my lonely host up there that I created that I just directly connected to the internet. And then here is the router that was defined. Here are the subnets that were defined, and each of these networks have a number of hosts. These 2 both had just 1 as the default. This one had a web server as well as the 5 that I defined, 1, 2, 3, 4, 5. And if I hover over those, I can get the information. That's Linux host 1, Linux host 1. That's what's inside the template, but you can change that in any way you want, okay? So let's come back here. All right, I know that was a lot at lightning speed. So we went from getting better to the environment files. This is just a view of those 2 different environment files, one for Linux, one for Windows, where I have that resource registry saying that OS Nova host could be this URL, which defines a Linux YAML, or it could be this URL, which defines a Windows YAML. By the way, I'm defining like a single instance inside of that. If it points at a YAML, which is 5 different hosts, you know, a web server, an FTP, and whatever, then that's what that resource is. How cool is that, right? So you can see that there's a lot of flexibility and modularity in the way that you can approach this. So some of the things that I wasn't able to go over, dependencies. As you're creating more robust and complicated things, you need to think about if something needs to get something else, then you have to use the depends on condition inside of that resource to stop it from trying to create something before whatever a dependency is completed, okay? So that's a consideration. Conditions are very helpful. Nesting of templates is key. Again, this gives you that flexibility and modularity. So you saw those templates and what was in them. When I found the Trump hair OpenStack, I kind of had to use it. I just found it, okay? And I had to use it. So just so you know, threats are everywhere. Get better at the tools you're using. And my thing is, yeah, it's hard, but don't let that stop you from learning how to use it well. And use it for what you need it for, not just for everything. So that's it in a nutshell. So I'm going to try to open it up to questions, because there's probably questions. Or not. Yes? Heat. So that's actually the project name for the orchestration for OpenStack, for the OpenStack framework. Heat is that project name. So like Nova, for example, is compute. That's the project name. So when you say Nova, that's what you're referring to. Keystone is the identity authentication piece of it. So each of those names are related to that. And so like I said, you see some of them up here. Cinder, Glance is your image. Neutron is network. So those are all there. Questions? Yes?
Building an open stack, do you have a particular distribution you recommend that would be easy to initially learn?
So this was really more focused on using the projects, right? I think Chris, yeah, I'm calling on you. He has a lot more experience with like what he might think is the best thing to build it on. I would agree with that. I saw a question in the back. Yes.
Dealing with Neutron, and this is probably a side question. You were showing your topology and had different segments running. Is there a easy way to set up a network tap utilizing Neutron? In other words, get it from one segment to another segment, say a monitoring segment, easily?
So with Neutron, I'll tell you that I've already kind of had to look at that. With Neutron, I really didn't look for something in that flavor. What I decided to do was go with a CSR 1000, and I'm talking about inside of a project for training purposes, was to go with the CSR 1000V, which is a cloud router from Cisco. When deploying that, you have the same ability that you would on any like Cisco iOS XE, whatever. So you can mirror everything that pushes through that onto another port and connect your sensor there, because it's all software defined. Yeah, I'm looking really at from a user's perspective and creating this for a user environment. Any other questions? Okay, so I'll just finish off with, I think I have to give things away. I feel like if someone can tell me what HOT stands for, that would be pretty good. Go ahead. Orchestration template. Yes, that is right. You pass that. You pass that back there. Okay. Let's see. Let's get crazier. If I wanted to refer to a parameter and pull that in to define a value for a resource to depend on, how would I get that parameter? What kind of function? Like, what's the function call? Go ahead. Yep. These aren't very hard questions. Okay, and is OpenStack a hypervisor or a cloud framework? See, like so easy. What is it? Okay, so easy. Pass that down. Thank you. And like I mentioned before, if you would like access, I have the URL on here, and I can, if you search Trash Panda with a 5 instead of an S, it's on GitHub, and it's all public. So all these templates plus the website are all public. So if you'd like time on a OpenStack range, the same one that I demoed all of this in order to be able to play with this yourselves and customize these templates, please let me know, and I am happy to get that to you. Trying to pull it up. So this is these will just take you to the repository area where all of those are at. The basic information goes over a whole bunch of the stuff that I covered today, as well as points you at CLI instructions, and then this is a step-by-step getting started just in the GUI and trying to use it. again, and then this is the instructions if you want to use the CLI. And that's all.